Okay, so welcome to the second devlog of OpenCat. So actually the first devlog was already edited by this software, but I noticed that the exporting is very slow. So in this video, I want to share with you how I made the exporting roughly 33% faster. So of course with the help of AI, because I don't understand Rust and I don't understand GStreamer, which is the underlying media engine I am using. So of course the first thing I tried to do is simply asking AI. Here I am using both Codex and Cloud Code to just asking AI why my exporting is slow, and so the AI will scan this file. This file is like 800 lines of code, and they will give me some suggestions, but it turns out it's very hard for the AI to just look at the code and find answers. And then I also tried to add the hardware encoding version because I am on macOS. So I added the video toolbox encoder option, and I only got like roughly 6 to 9% faster. Because I then used this flame graph tool to benchmark my exporting. Then I found out that the encoder actually only took roughly 20 to 25% of the time. So although the hardware encoder is faster, but because it only takes less than 25% of the time in total, then this encoder optimization is not the main problem for the slow exporting. Without actually running the code and extract the important part, AI cannot optimize your code magically by just looking at the code, because once the code gets complicated, just by looking at the source code does not help. So then I asked the AI to actually write an integration test here, because doing it this way, I am no longer in the UI. The UI is not the slow part, right? It is the actual exporting. So I write this integration test, and then I asked the AI to do a flame graph of this integration test. So the AI is able to look at the flame graph and figure out what's actually making like which part is taking more time. And then we found that actually the conversion and scaling and takes a long time, because I am exporting 180p, but my source video is only 480 and 720p. So the exporting engine needs to scale up my source frame first and then do the export. I am actually using single-threaded scaling. So I asked the AI to add multi-thread scaling. So if we run our integration test, even for the software integration test, it takes roughly 10 seconds. You say 11 seconds in the software encoding. If we go to the previous version, single-threaded scaling and conversion, and let's run the software encoding version, and that takes 16 seconds, right? So it's like 11 seconds multi-threaded scaling vs 16 seconds single-threaded scaling. So that's the actual offender. The information I want to convey in this video is that actually with the help of AI, good software practice is even more effective. Because in the old days, before AI, like all the companies I have worked with don't really pay attention to tests. At least test is more like an afterthought, or like just a rule that you have to obey. And a lot of engineers don't consider testing as a way to explore a system, to investigate the system through writing tests. Because writing tests cost a lot of time, doing benchmarks cost a lot of time. But now with the help of AI, we can just have a plan, have a concept of test in our mind, and just tell AI to do this kind of test for me and get the result back. Optimization is like detective work. With AI, you can do detective work much faster. And I think a good engineer needs to have those two different mindset. When you are writing new features, it's like a construction worker mindset. But when you are doing optimization or debugging, it's like a detective mindset, or it's like a doctor, like a surgeon mindset. It's very different. With AI, I feel like the detective mindset can be much more powerful and much more stronger. And it's kind of ironic that like this is only 4 days of vibe coding with Rust. This editing sequence, like there are a lot of clips, but like the zooming is so smooth, right? It's so smooth. Like, and this is a debug build. This is not release build. If I play it, it's like 90 or 89, 90 FPS in debug mode. But here is like the media is missing. You can ignore that. But this is CapCut. It's by ByteDance, a multi-billion-dollar company, and with only less than 7 minutes of video, and the zooming is like so lagging. And this is a production build. I don't want to shit on CapCut because I still use its AI feature to generate all those subtitles. And let's look at our release build. Remember, this is just vibe coding. 4 days. I do not know video pipeline. I do not know Rust. Like, I'm just a JavaScript programmer. I am vibe coding Rust in order to learn Rust. Let's take a look at our release build. Easily more than 110 FPS. And I can play our preview and doing the zooming in the same time. And everything is so smooth. So what I want to say is, actually with the current level of frontier models, you can absolutely beat those big techs. If you think about it, the big tech has to hire like maybe 20 or 50 or 100 programmers to work on one product. And maybe 10% of those programmers are very good. So if it's like a 50 people team, 5 of them are very, very good, and they are better than the frontier models in their specialized domain. But the rest 45 of them probably suck, or like they don't suck, they are just like you and me, but they're not as good as the frontier models. But they have to do that 3 or 4 years ago, because there's no other options to like write 5,000 lines of code every day. But now with the help of AI, an average programmer like you and me can actually write better code than the average big tech programmers. Maybe it's still not amazing, but our starting point is already bigger, already higher than the average big tech. So this is like 16 or 17,000 lines of code. So that's on average 4,000 lines of code every day, because it's only 4th day. Basically, at least at the bootstrapping process, which means like the first 100 days or the first 1 month or so, your productivity is at least 10 people equivalent in the like pre-AI era. Now we can actually have good stuff with agentic engineering or vibe coding, or however you like to call it. This makes me like to code again. And it's kind of amazing.